As we work with these quadratic equations, what we're going to talk about is using the quadratic formula, and that is to solve these quadratic equations, which can't be solved with a more simple method. The quadratic equation is tried and true. It's going to factor the quadratic formula is tried and true. It will factor a quadratic equation. It just may not be the shortest method, but it's guaranteed to be a successful method if you do it properly. So we want to find the real and complex solutions of quadratic equations using the quadratic formula. We have done that up until now we have found real solutions, but we haven't done complex solutions. Now that we're delving into the complex number, that allows us to find those. And then use the discriminant to determine the number and types of roots of a quadratic equation. And again, we have in algebra done the quadratic formula finding the real roots, and then we'll talk about how to distinguish between real and complex. In case this should jog your memory, this was the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. It is important that you understand that the standard form is where we derive the b where those come from. They're coming from our quadratic equation. And then we're going to talk about the discriminant, which should be familiar to you also. The discriminant is just going to be this radicand portion here, the radicand found in the quadratic formula used to determine the number and type of solutions of the quadratic equation. And then, of course, the quadratic formula is a formula for finding the solutions of a quadratic equation in standard form. In practice, there's 4 steps. Step 1 is that we need to write the equation in standard form. It needs to be in standard form to where we get the right sign and quantity of the a, b, and c. Step 2, we identify the values of a, b, and c. We identify what those are, and if you'll notice, a is the coefficient of the x squared term, b is the coefficient of the x term, and c is going to be your constant out there. We identify those values because those are the values that we're going to substitute back into the formula. Once you substitute it back into the formula, you're simply going to simplify. So it's, again, it can take a while, but it is genuinely a straightforward process. So as we talk about the quadratic formula, we want to take this example and we want to go ahead and solve for x. And in doing so, we're going to use the quadratic formula. So remembering that the quadratic formula is going to be, x is going to be equal to negative b plus or minus b squared minus 4ac, all of that over 2a. So we go ahead and write it in standard form, and as we can see, it is in standard form. You have 5x squared plus 3x minus 4 equals 0. And let's go ahead and identify what my a value is going to equal, my b value is going to equal, and my c value is going to equal. So my coefficient a is 5. My coefficient of the x is 3, so b is 3. And then my constant is going to be negative 4. So those are going to be the values that we're going to input back into the formula. So I'm going to have x equals negative, and b is 3, plus or minus. And we just said b is 3, right? So 3 squared minus 4 times a, which is 5, times c, which is negative 4. All of that is going to be over 2a, which a is 5. All right, so we've done our substitution of the a, b, and c values back into the quadratic formula. Now we need to simplify. So x squared is going to be equal to negative 3 plus or minus 9 plus, because I have a negative 4 times 5 is negative 20, and then negative 20 times negative 4 is going to give me a positive 80. So there's going to be plus 80. All of that is going to be over 10. and that is going to simplify down to -3 plus or minus the square root of 89, all of that over 10. And we could probably leave it there. I don't know that there's any perfect squares in 89, so I can't really simplify that radical anymore. And so I could say if I wanted to leave it like that, that would be a proper answer, unless they said they want it to the nearest hundredth, okay? That would be the second decimal place. So I would go ahead and continue here, and that would become, remember, this plus or minus created two problems. So I have x is going to be equal to -3 plus the square root of 89 over 10, or x is equal to -3 minus the square root of 89 over 10. I'm going to grab a calculator to figure out what the square root of 89 is. All right, so it looks like, I'm going to put it over here, the square root of 89 is actually equal to 9.433, and I'm going to go ahead and just call it 9.4, so x is equal to -3 plus 9.4 over 10, or x is equal to -3 minus 9.4 over 10. So this becomes x is equal to 6.4 over 10, or 64 over 100, or x is going to be equal to -12.4 over 10. So there's my two possible answers. So I was able to go down and figure that one out. Now, if I was to go to the nearest, again, 100th decimal place, I should probably put that in. The nearest 100th decimal place, I should have just said x is equal to 0.64, and then x is going to be equal to moving that over should be -1.24. So those are my two possible solutions there. Solutions. These were two possible real solutions. Two real solutions. Moving on here, solutions. So now we talked about, so when I look at this, I look at what do my graphs look like. So if I have two solutions means my quadratic equation is going to cross over my x-axis twice. And here it happens to be crossing over at 1, and here it happens to be crossing over at 4. So my solutions are x equals 1, x equals 4, because that's where my y equals 0, and then finding that. So if I have it where it just touches and just goes away from the x-axis, that is considered one solution, because it only touches the x-axis one time, and it happens to be at x equals 3. When we have that's two real solutions, sorry. One real. And then here, if I have it up here, that is no real solutions, because it does not cross over the x-axis. That would be considered two imaginary solutions, because it does not cross over the x-axis. And that's really where we're going right now, is that we're able to solve for that now that we couldn't in the past. And if I look at this graph down in the bottom, you should be able to just look at this and say, okay, this green graph right here, it touches the x-axis 1, so it has one solution. And then the yellow graph doesn't touch at all, so it has no real solutions, but it does have two imaginaries. And then my red equation, I should be able to look at that and say, well, that has two real solutions, because it goes over the x-axis twice, here and here. So those are the kind of things that you should be able to recognize from a graph. Now, when you have no real solution, what is that going to look like? Well, we're going to do the same thing that we did before. We're going to, with this example, I'm just going to turn it around just because we are used to looking at it in a certain direction, but it does not matter. And then I'm going to say that A is going to be equal to 5, right? Here's my A. B is going to be -2, and C is going to be 6. B is -2, and C is going to be 6. Now we're going to substitute that into the quadratic formula, sorry. And remember that is x equals -b plus or minus the square root of b squared minus 4ac. And all of that is going to be over 2a. Okay, so again, going to substitute in these values. So I'm going to have negative b plus or minus the square root of b squared minus 4. A is going to be 5, and C is going to be 6. All of that over 2a. And as we go to simplify, remember that this is going to, negative times a negative will become a positive. Negative squared will become a positive. -4 times a positive 5 times a positive 6. This is going to be negative on this side, and this is going to be a positive 10. So I'm going to have x is going to be equal to 2 plus or minus the square root of 4 minus, looks like that is 120. All of that is going to be over 10. So x is equal to 2 plus or minus the square root of -116 over 10. And again, back in the day, we would have stopped here when we saw this negative number in there because we couldn't find the square root of that, but we can now because we're going to create a complex number, imaginary solutions. So we're going to simplify that root, and I know that I can say 2 plus or minus. I'm just going to go ahead and work just this portion over here, and I'm going to say the square root of -16 is going to be the square root of -1 times 2 times, I want to say 58, which is the square root of -1 times 2 times 2 times 29. And I may be done there, okay? But I know that the square root of -1 is going to be I. I know that the square root of 4, 2 times 2 is going to be 2, and that leaves behind in the radical a 29, okay? So now I'm going to bring that back over here into my problem. So I have 2 plus or minus 2i square root of 29, all of that over 10. And that's starting to be an answer, but I do need to simplify. I have these fractions that I need to simplify. So that is going to be x equals, and I'm going to split this up just because fraction causes people a hard time, and I want you to see it. So I have that common denominator, and this is going to simplify down to 1/5. This is going to simplify down to 1/5, and then this can't be simplified anymore. So that becomes x equals 1/5 plus or minus 1/5 I square root of 29, something very cumbersome like that. And of course it would be easiest to rewrite that as x equals 1/5 plus or minus I square root of 29, or 1 plus or minus I square root of 29, all of that over 5. There you go. There's my two imaginary solutions. A positive, and then a negative. Working with the positive and then working with the negative. or using the discriminant. Okay, the discriminant, when we look at the quadratic formula, is going to be this portion right here, b squared minus 4ac, because that is going to determine the number of solutions that we have, and types of solutions. And if you remember, if this discriminant is greater than 0, that means it's positive, and we can find two solutions from a positive number, the square root of a positive number. If it is equal to 0, we're going to find one solution, and then if it is less than 0, that means it's negative. We're going to have no real solutions, but we will have two imaginary solutions. So just keep that in mind, that it does identify that. So using the discriminant, we do need to identify what my A, B, and C are going to be. And A is 6, B is negative. Oh, goodness. I'm jumping the gun here, and I'm doing it all wrong. Let's look at this example. 6x squared minus 8 equals 4x squared plus 7x. Well, I need to write it in standard form. I almost skipped my first step. So combining like terms, I'm going to move. I'm going to have, that's going to simplify to 2x squared minus 8 is equal to 7x. I'm going to go ahead and subtract 7x so I can get it on the side I want it on. And I'm going to have 2x squared minus 7x minus 8 is equal to 0. And A is going to be 2, B is going to be negative 7, and C is going to be negative 8. You notice I did not use the variables when I identified A, B, and C because those are just the coefficients and the constants. I am only concerned with the number and the sign. Okay, so when I fill in my discriminant, I have the square root of b squared minus 4ac. So the square root of b squared, which is negative 7 squared, minus minus 4, and then a is going to be 2. And then c is going to be negative 8. And continuing on, that is going to be 49 plus 64, which is going to be 113, and that is a positive number. So if we have a positive number in the discriminant, it is greater than 0, and that is going to be two real solutions. If we go ahead and simplify our next example and put it in standard form, let's see here, combine my y's, right? So I'm going to subtract 3y from both sides. I'm going to have y minus 7 is equal to 5x squared minus x plus 2, and I'm going to go ahead and add 7 to both sides. I'm going to have y is equal to 5x squared minus x plus 9, and then go ahead and make that 0 is equal to 5x squared minus x plus 9, so I can solve using the quadratic formula. And a is going to be equal to 5, b is going to be equal to negative 1, and c is going to be equal to 9. So when I fill out my discriminant, I have b squared minus 4 times 5 times 9. And that is going to be the square root of 1 minus 180, and then the square root of negative 179, which means if we have the negative 179, that's going to be no real solutions, but it will be two imaginary because it is a negative number and we cannot find real solutions from a squaring a negative number. Okay, so that is working with the discriminant. That is working with the quadratic formula for finding the types of solutions. And just remembering that in the quadratic formula, write the formula out. Don't skip that step. Don't sit there and try and do it in your head. You're going to get it wrong every time. And then when you get it wrong, you're not going to know where you made your mistake because it's not going to be on paper for you to see. So go ahead and write it down every time. Make sure you do your substitution and then start to simplify. Don't put it in as one big calculator action. You're guaranteed to miss it. Remember, your discriminant will identify what your number of solutions and types of solutions. And also in your step here, first step is write it in standard form. Identify your ABCs so you can input them. Input those ABC values and then simplify. And that's it, the quadratic formula. Not the most efficient way, but guaranteed to factor any of your quadratic equations.